Okay, you remember what we did yesterday again? Yes. What is it that we did yesterday? Algebraic equation again. Yes. And we were using the additive and the multiplicative inverse again. Yes. So we're solving for x using the multiplicative and additive inverse. So today, what we're going to do, we're going to do solve for x, but our method is going to be different from yesterday. Our method is we're going to use the law of exponent. Let's use the law of exponent to solve for x. I'm going to write it here to say is law of exponent. But on this law of an exponent, we have the algebraic equations. Under the algebraic equation is what we're going to use. The law of an exponent is what we're going to use to solve for x. So that means it's a mixture of the two. It's a mixture of the algebraic equation and the law of exponent. So since we're still on a law of an exponent, I want to remind you of the laws of exponent. We did laws before, but those laws are also going to come into play into this because now we're supposed to apply those laws in order to solve for x. So let's just recap on the law of an exponent. You remember there was this law of a to the power n multiplied by a to the power n equals to a to the power n, but you add, you add, and the other one says a to the power n divided by a to the power n is the same as a to the power m subtract n. So, and we have another loss of an exponent where it says that a to the power m to the power n is the same as a to the power m multiplied by n. And the other one, it says that if we have variables in the brackets, the exponent, it belongs to all the variables that are there in the brackets. So which is a to the power n multiplied by t to the power n. You distributed n to each variable that is on the bracket. And the other one says that anything to the power 0 equals to 1. And the other one, we say that a to the power subtract n is the same as 1 over a to the power m. So that is what the law of exponents that we have discussed before. And now, we did an algebraic equation. And on the algebraic equations, we're supposed to integrate the algebraic equation with the law of an exponent. So now, on this one, for example, I'm going to say that solve for x. Let's say the question says solve for x. So when you solve for x and we have a, x to the power 3 equals to 8. If it's x to the power 3 equals to 8, no, let's do this one. Right? Okay, it's not x, it's 2 to the power x. Yeah, the question is like this, to say 2 to the power x equals to 8. So us, when we solve this kind of a situation, what we need to do is to make the base to be the same so that we can take the exponent. So now let's look at this. If we have 2 to the power x, that means the base should be 2. That gives us 8. What is the base of 2 to the power that can give us 8? 4. 2, So we're going to say 2 to the power x equals to 2 to the power 3. So now we have converted 8 into an exponential form again. So we converted 8 into an exponential form. So now the bases are the same. If the bases are the same, we equate the exponent. So what is our exponent? Our exponent is x and 3. So therefore we're going to say x equals to equals to 3 again. Okay, let me give you another one to say, okay, let's take this one as b. I want you to try 2 to the power x equals to 16. I want you to try it. Solve for x. Solve for x. X equals to 16. So let me just try to say, when you do this, the first step that you do is say, you write the constant. You write the constant in the same base as the 10 with exponent. What's the first step we must do? Write the constant. Which one is constant?
2.
It's 2. No. 2 is not a constant. It's an exponential form again. 16 is a constant again. And the method says that you should write the constant in the same base as the term with the exponent again. So what is the term that is an exponent? It's 2 to the power 8 again. So that means our duty now is to write 16 at the same base. That means 16 should have a base of what? Of 2. So what is the number that is going to power that can give us 16? If we have 2 as a base, what will be the power so that we can get 16? Okay, we can start saying 2 to the power 2 to what? 2 to the power 2 is 4, then 2 to the power 3? 2 to the power 4? 16, then. That means we write 2 to the power x equals to 2 to the power 4. That's the first step. And the second step, we equate the exponent. What is the exponent? It's x and 4. We equate x and 4. So we equate x and 4. X is equal to 4. So that's how we do it again. Anyone with a question? Yes. No, it's wrong because we don't have the same base. We must have the same base first. Okay? So here, you can see here, all of them, we can only equate if they have the same base. Okay? So now we cannot say if here was 4 to the power 2, we cannot equate them because they don't have the same base. Remember the first step says that write the constant, which is 16, in the same base that this is 2, that has an exponent, okay? So therefore, if you wrote 4 to the power 2, it's not the same base. We want something that has the same base as the exponent. And the one that is the same base as exponent is 2 to the power 4. Okay, let me give you this one. I want you to give you number C here. Number C is 5 to the power x subtract 1 equals to 125. I want you to do this one. The first step, remember the first step. What is the first step? You write the constant
In the same base as the term
with the exponent, right? So that means our base there, how much is going to be? What will be? Our base is going to be 5 this side again. So I want you to figure out the exponent. So write it down. And after that, you create So if the base is 5, what will be the exponent? 6. Okay, the other way, remember that if it's 5 to the power 2 is the same as 5 multiplied by 5, again. And 5 multiplied by 5 will be like 25. Then you say 5 to the power 3. 5 times, we get 5 multiplied by 5 will be like 25 again. 25 multiplied by 5 will be like 125 again. So that means it's 5 to the power 3. So we're going to say 5 to the power x subtract 1 equals to 5 to the power 3. So what is it that we're going to do now if the bases are the same? What is it that we equate the exponent, right? Yes. So the exponent is x subtract 1 and 3. Right? So we're going to say x subtract 1 equals to 3. Did you get the x? Yes. No? We did not get the x again. So that means we must, what is it now? Can you see? This one is the same as the equation that we did last time again. Yes. So if we have the equation like that, what is it that we must do? Yes? Additive inverse. Additive inverse. What is the additive inverse of negative 1? What is the additive inverse of negative 1? Positive 1. So that means we're going to add positive 1 both sides. So it's going to be x subtract 1 add 1 equals to 3 add 1. So negative 1 add 1 is 0. X is equals to 4. Okay. Now let me give you another one, number D. Let's do number D. Let's do number D. Number D we have and the second step, we do this. We equate the exponents. Only if the base are the same. So these are the two steps that we're applying. The first one, write the constant in the same base as the term with exponent. After that, we equate the exponent again. So did you do step number 1 here? So you write the constant in the same base as the term with the exponent. The term with the exponent is 2 again. So that means our base is going to be what? Our base is going to be 2. We're going to say 2 to the power x and 3 equals to 2 to the power 2 to the power 3. So now, what is the second step that we're going to do here? We equate the exponent. So it's going to be x and 3 equals to 3. So now we simplify again. How are we going to simplify? Additive inverse. What is the additive inverse here? Negative 3. So we're going to say negative x and 3 equals to 3 subtract 3. So negative 3 and 3 buka.
Negative 3.
0.
0.
So we have x is equals to 0. Right? Okay, let's do another one. Where is number E? We have 7 to the power x and 1 equals to 1. So, are you done? Yes. Okay. How do we change the constant to be in an exponential form with the base of 7? How do we change 1 to have the base of 7? And look at the law of exponent again. And on the law of exponent, we have another one, the last one, the second last. It says that anything to the power 0 is equal to what? 1 again. So then we're going to use that law of exponent of anything to the power 0 equals to 1. So that means 7 to the power 0 equals 1. So we're going to say 7 to the power x and 1 equals to 7 to the power 0. So we wrote the constant in the same base as the exponent. Now the bases are the same. If the bases are the same, what is it that we're going to do? We equate the exponent. And we're going to have x and 1 equals to 0. Right? And when we are here, we use the method that we learned last time to say we add the additive inverse of 1. What is the additive inverse of positive 1? Negative 1. Eh? So it's going to be x subtract, add 1 subtract 1 equals to 0 subtract 1. So therefore x equals 0 subtract 1 equals negative 1. Eh? Okay, I'm going to give you another one. Yeah? As number. Well, in here, let's do f. And f is going to be x to the power 0 equals to 1. X to the power 0 equals to 1. Okay, this one is too extreme. Let me delete it here. Yeah, this one is too extreme. Let me hear something that's on that we can able to do. Yeah? So, yes. Oh. Yeah. Okay. 10 to the power x equals to